Good morning, everyone. Thank you so much for attending. We'll get this webinar show on the road here. I appreciate you being here. We're going to talk about plant benchmarking, best practices, some real value, starting with downtime. And we've got, I think, some really interesting things to talk about that might give you some good perspective on what various manufacturers are doing, what's going on with some of the companies that you might know, or companies similar to yours. As a introduction for us, hold on, got to get my stuff working here. For us, Ectobox, we're what we like to call an industrial intelligence solutions company. We're really focused on helping companies drive innovation with data to help revolutionize their business, using industrial intelligence solutions for the manufacturing businesses to drive efficiency and growth. I'm Kevin Jones, CEO of the company, and we're here to provide you with some good background, some good information to give you some perspective on what's going on from the perspective of industrial intelligence solutions, the Internet of Things in manufacturing. So with this, we'll start off with some basic ideas around a couple of studies that we have. But as an overall introduction, manufacturers have access to real-time data about operations, or at least those manufacturers that do have access to real-time data about operations. And the manufacturers that have data-driven decision-making processes that are applied against established KPIs are the companies that have the distinct competitive advantage against all the other companies. The companies that don't have this data are going to struggle and in growing and competing. And that's the premise of this whole discussion here. So we'll talk about some benchmarking of companies, where they're at with their visibility into operations using IoT, and review some of the technical side of IoT projects so you can have a basic appreciation for what happens behind the scenes. And we'll also talk a bit about what happens after that first IoT project. And we're going to keep things relatively light here. We won't get into a bunch of details so that we can respect everybody's time. We are working with this 30-minute format for webinars so that people have time to fit it into their day rather than a full hour. And with that in mind, we try to cut to the chase on a lot of items and not get into a lot of details. But if things come up, if you have questions, feel free to ask. I'd be happy to talk with you about them later, or have somebody in our team talk with you about them later to answer your questions and see where that conversation goes. So like I've said, companies that have the data, use the data, will be able to compete and succeed. And we'll see this in some of the results of a couple of studies. And the first one is a short study that we did for manufacturers that we were working with and that we are talking with. And we looked at some of their basic top challenges. And in this basic top challenges, I've excluded the workforce challenge. That's something that everybody is dealing with, trying to get enough people to run the machines and work in the shops who are reliable, will show up on time and get things done. Essentially smart people that can get things done. They're in short supply. The interesting thing is that the solutions that we're going to be talking about here in manufacturing IoT can really help with that, along the lines of use what you have to continue to increase the business and what you're capable of. But putting that aside, we've surveyed these companies, and we've found that the great majority of them have challenges with either no visibility to data at all, or limited visibility of real-time production data and WIP, or work in process data. And the companies that have that limited visibility were those using manual or paper or analog systems, and also Excel, very basic systems. There were other top issues that they talked about where they had some quality issues or production efficiency issues, but it was remarkable that a lot of the companies really don't have any visibility on data in production, or they were working with a lot of manual data. At the same time, nearly all of them tell us that they have more orders than they can fill, and therefore they want to grow production and revenue let's try to fill all these orders that we have in front of us, or that they want to be able to preserve their margins and their profits by increasing their production efficiencies and reducing costs. They want to grow, but maybe they don't want to grow like crazy. They don't want any kind of exponential growth, but they want to keep a good, modest 10, 15% growth, whatever it might be. But at the same time, they want to preserve their margins and profits and increase those margins and profits. So the issue, though, becomes if they don't know where to make their changes, if they don't have the data about where to make those production efficiencies and how they can, what kind of knobs to turn, so to speak, on the big plant control board, so to speak, then they're not going to know how to increase those production efficiencies, et cetera. There's an expression I'm sure you've heard: what gets measured gets done. We could also modify that a little bit for this situation. What gets measured gets improved. So if these companies were able to get data directly from their operations, they'd have a better success in improving their understanding of where the issues are and tracking them. So, of course, you can see kind of what I'm saying here. Companies need data. Companies need information. Companies need KPIs so that they can understand where their issues are and then start to solve them. And they can compare their performance to their KPIs. Here are a couple of examples of some companies we've talked with pretty recently. There's a company in our geographic region, $100 to $200 million $1 million revenue per year, precision metal manufacturing company. They have a lot of CNC machines. They're doing really well, more orders than they can shake a stick at, and they're buying more CNC machines to increase their capacity. One of the executives told me that leadership and ownership is probably pretty soon going to come around and say, no more new machines, use what you have. And again, the same kind of principle can apply to workforce as well. They believe they have the capacity to do more with what they have, but they don't know where that capacity is. They don't know how to get that additional capacity. So, of course, they're starting to look at ways to get that information. And they're starting with remote monitoring. Look at the causes of downtime. Look at the reason codes for downtime, for unplanned downtime, and then start to pick the low-hanging fruit and go from there. That's going to go a long way to helping them work out what's slowing them down, number one. And number two, it's going to start them down this IoT journey to allow them to do a lot more in the future. Another good example is a foundry in our geographic region, $50 to $100 million gross revenue per year. They're running well. They have good margins, good profits, a lot of orders, more orders than they can also shake a stick at. And they also see increasing costs and competition in various areas. And they want to get better. They want to work more efficiently. Therefore, they've realized they want to get real-time data to see where their work in process is at, to get process data so that they can improve quality over the long term and short term. And currently, a lot of their process internally rely on, or at least the reporting of data relies on paper and Excel. Not an uncommon situation, as you can see. So they're looking at ways and working with us to look at ways to pull the data from operators, from devices, from machines to get that real-time data, establish some dashboards with KPIs and measure against those KPIs. So what does this tell us? Connecting to machines and people and processes and pulling the data out and measuring against KPIs is a key to enabling companies to produce more and to produce more efficiently and to grow. And it also tells us that companies know this and that they're looking to make this transition. They're looking to make the changes to get IoT solutions in place. And we'll see this bear out in another study that we have. This is a larger study that goes a bit deeper. And again, you'll see some of the challenges that these companies face overall, what kind of setups they have now for data around their operations, and what their perspective is on the value of that data, and where they're at in that journey. This research study was done by Informa Engage and also Industry Week. And the research study was called the Multi-Plant Management Performance Benchmarking and IoT Study. That's a mouthful. And this was done, the study was performed to gain an understanding of where leaders are at with their manufacturing operations and overseeing them with data. And it's for manufacturers of multiple plants, more than one plant. The data was collected in December 2018 and January of 2019. A total of 211 surveys were used, and those surveys were with C-level people, VPs, directors of companies, the real leaders in the companies at the top levels of the organizations. And again, with companies of more than one plant. Let's start by looking at some of the KPIs, some of the challenges that companies have. The challenges that we see here are similar to a lot of other companies. Quality, delivery performance are the top two. And then down from there, production output KPIs, on-time delivery, and safety. And then continue down from there, sales, labor cost, rejection, scrap. Downtime is also still within the top half of the group for the biggest challenges that the companies need KPIs around and want to measure. Another perspective is the how senior management gets their data. Currently, about 20% are getting the data which is produced in a completely manual form, assembled manually. Another 50% of the data that companies and senior managers are using is a mix of automated digital information and also manually compiled information. So about 70% of the companies, the senior management, about 70% of the data has some manual or analog component to it. And this is a problem because manual data can often have one or more of three issues. And that manually assembled or analog data can be late because it takes a long time for somebody to write it down on a log sheet, on a clipboard, to enter that data into some digital product, whether it's an Excel file, which is really common. Even just earlier this morning, I had a conversation with a company where they're still entering data in Excel or entering the data into an ERP system for basic analysis. And then having that data analyzed or processed into charts and whatnot, and then eventually getting it in front of the right person to be able to look at it. The second issue is typically the data is limited because humans can't enter nearly as much information as a machine can, obviously. And also that data is not always going to be perfectly accurate because humans are involved. And also because if there is manual data and processing of data, there's not only the mistakes that will happen by humans, and I'm one of them, I make mistakes, but there's also an issue where there will be fudging of numbers. And I'm sure a number of you probably have seen that before. I had a conversation with a company last week where they said they were trying to measure OEE and do it manually, calculating it manually. And the company was trying to get people to learn what OEE is and the three parts of OEE, and to get the operators and supervisors to really understand it and then understand the impact they can have on operations. But it turned out that they were actually fudging a lot of the numbers to make things look better. In some respects, not surprising, but sad also. So with all of this in mind, the difficulty of gathering that data becomes pretty significant, I think we could say. There is a lot of time. 11% of companies report a lot of time and effort that's put into getting that data, and it inhibits companies from being able to use that data. 21% of companies, pretty still, maybe not a massive amount of time and effort, but still a significant amount of time and effort. And 41%, there is still probably, let's say, a modest amount of time and effort to provide that data. And if you look at a company that wants to become data-driven, truly data-driven, that means automated, digitized data. And anything more than it takes more than just a little bit of work to get that data, then that data likely isn't going to get processed, or it's going to be old, late, inaccurate, etc., and limited too. So if we were to add all of these up, 41, 21, 62, 73, nearly 3/4 of companies are spending anywhere from a modest to a significant amount of time and effort to compile the data. That's that's a lot of effort. That's a lot of time where they could be spending that time and resources doing other things, and while systems on the background could be providing that kind of data. All of this speaks to the fact that leadership at manufacturers are now working reactively on the data, and that data can be anywhere from 1 to 2 weeks old or older sometimes. Now let's step over to talking about the value of data. And here the study looks at the value of data by looking at the frequency of any of the digital data that's accessed. So for the companies that have that automated, that digital data, they are looking at that data more frequently. As you can see on the left, weekly and monthly is where they're really looking at that data. And that indicates that companies really see the value of that data, and if they have it, they will use it, which is a good thing. However, with these kinds of solutions that are required to put things into place, IoT solutions, pulling data from machines, pulling that data over a network, converting that data to valuable information, and then presenting it to the right people at the right time, there are some obstacles. Some of these obstacles are, I think, sometimes maybe more perceived than real, but that's something that we could all have a good discussion over drinks. Some of the top obstacles: lack of expertise. And I think here the lack of expertise is probably more internal in these companies in their perception. The expense of the solutions, machine and device connectivity, those are the three biggest ones. And then there's lack of executive buy-in or support, which I think is a really important one too. For each of these, in our minds and in the minds of some companies that we work with, these are all solvable problems. These are all solvable issues. Lack of expertise can be addressed through working with trusted partners. A lot of manufacturers, we've seen some studies in some places where manufacturers are now working with more and more trusted partners and creating those good, solid, long-lasting relationships with partners, more than they have in the past, because they need to, because manufacturing is getting more complex. There's so much involved, and you can't be expert in everything, and you can't always employ all the people to be expert in everything. You need to bring people in to help you. And so that's where the expertise can come in. But also something to think about, and this is something that we practice as well, manufacturers should be looking for their partners in IoT platform implementations, their integrators, to provide education on those products, not just come in and solve, see you later, and then call us for every problem you have. No, it's let's help you with this process. Let's train people. Let's get you up and running on these products so that you can then sustain them over time and grow these solutions over time on your own. Call us for the heavy lifting, but be able to move forward with it on your own as well. The expense, that speaks to being able to pick out the really high value situations, and then it's not an expense. You're actually looking at it as a business case with an ROI and investment, and then able to actually help move the company forward by putting those solutions in place. And the machine and device connectivity, not a big thing. It is difficult sometimes, but there are tools out there to help you, and the experts who can come in can help you with that connectivity. The real crucial thing, though, is the lack of executive buy-in. Nothing happens without executive buy-in, and that's the thing that I think companies struggle with a lot. But once that executive buy-in happens, and once companies understand how to approach IoT, which we'll talk about a little bit, then it becomes really interesting. And the status with IoT. So clearly companies recognize IoT as valuable. However, based on the data here, most companies are kind of early in their journey or haven't really started it yet. 26% of companies have deployed or are deploying solutions. But that leaves nearly 3/4 of the companies that are planning or exploring or have no plans at all. That's a huge opportunity for companies that are really looking at making advances with IoT, pulling data from machines deeper in operations to get better data, and to create that data asymmetry between yourself and your competition. It's a huge opportunity for companies against their competition to get that valuable data and then push their competitive advantage in big ways. So with all of this, to summarize, I mean, companies have challenges with manual or analog reporting systems. They recognize the value of that data, and they see challenges in getting those IoT implementations in place. However, I would suggest that they think about the competitive advantages that are available and the fact that these challenges can be overcome with the right approach, so that they can then start to pull the data from their systems and become a true data-driven company and create that data asymmetry. IoT is no longer new, and IoT isn't rocket science. It truly is not rocket science. It's simply a set of various technologies pulled together to enable certain valuable business outcomes. It's a set of various technologies pulled together to enable certain valuable business outcomes. That's what IoT is, and it's possible. So it's simply a matter of making the right decisions at the company to start the exploration efforts and then go from there. Let's talk a little bit about the behind-the-scenes look at IoT. We'll dig into some of the technical background so you have an insight on how it works, and we'll start with what you would potentially see in a final solution, the dashboards. All looks really pretty and very valuable and whatnot, and then we'll get into some enterprise-wide data for the plant. You'll be able to see that in the screens, and then we'll get into more of the technical stack, but we'll still keep it very high level so we don't get into too many details. So this is what some of the IoT solutions can look like. This is an actual implementation created with the PTC product ThingWorks. I should have mentioned at the beginning here, we are a certified PTC partner around the ThingWorks and Vuforia, or augmented reality products. And these are the kinds of solutions that we put in place for companies. This was a solution that was created, and then the names were changed to preserve the names of the identity of the innocent. So this solution is now for the Acme tractor manufacturing company. But this gives you a good perspective of the views that you can have for multiple plants, or even then a single plant, and the high-level KPIs that are available at the top of the screen: OEE, true efficiency, etc. And then down at the lower screen here, this is a good perspective on the data you can get on specific lines and downtime data, bar charts, Pareto charts, trend lines, other KPIs for the specific line, and then you can drill down to specific machines and work processes and get machine data, work data, WIP data, quality data, all kinds of things. It's just a matter of defining the business challenges you have in the business and then creating solutions around that. So a little bit more behind the scenes. We'll start at the bottom left. Let's say this is a stamping company. Maybe they're in the automotive manufacturing industry, tier 2, tier 3 supplier. A lot of stamping presses. Maybe they have some downtime issues. And there's a case study that we have that actually speaks to that specifically. And they want to get a better perspective on their downtime. They want to get some of these screens where they have this downtime data down on the bottom right. So what do you do? How do you put that together? Well, let's talk about a specific process first, and then I'll come back to that screen. The idea in IoT is to start with the business problem to solve. Select that business problem first. IoT is not a technical or an engineering tool. IoT is not an engineering tool. IoT is a business tool. So select the business problem to solve first, then define the business case, the ROI, and then start to plan a proof of concept. And in doing that, to prove that business case, define what information you need to solve that business problem. Information as an analyzed, processed information. And then, based on that information you need, define the data you need to create that information. Try to limit it as much as possible. Don't try to grab all the data from the PLCs and the CNC machines. You'll be overwhelmed, drinking from a fire hose. And then once you have those few pieces of data, those few tags of data to pull from the machine, then define the technology you need to get that data. And once you've done that, then you can start to execute the proof of concept. And in executing it, you then climb back up that stack. So climbing back up that stack, stamping press on the bottom left, let's connect that stamping press to a PLC if it's not already. And let's also set up a web application for the operator to be able to enter downtime reasons. Put that web application on a small tablet device, whatever it might be, Android, iPad, whatever, rugged case for it, magnet or Velcro it to the machine, wherever is convenient for the operator. Give them some data to enter, but limit what they can do so that it's very easy, it doesn't get in the way. And then connect both of those devices to or at least the PLC, and maybe the web application to a gateway edge device. And in this situation, maybe we'd use Kepware, an industry standard product for industrial connectivity. Pull the data from the PLC, and maybe the web application, or actually I could probably change this diagram. That data might come in somewhere else, but then push that data up to a very secure router. So we're talking security all the way through the system, from the PLC and web application, or even before, all the way through to the end. And then that data goes out of the manufacturing plant to a cloud solution, or that solution can be on-prem based on IT security requirements. And then that cloud solution, that's where the data happens. The gold in this whole situation is the data. The value is in the data, but the value happens in the IoT software platforms. And so with that, then ThingWorx will process the data, analyze the data, and present the data, the various views that everybody needs. That's how these solutions can look, and then that's where you can get these kinds of solutions. And if that proof of concept works, then rinse, wash, and repeat, but with a plan, which we'll talk about just very briefly. Digging a little bit deeper, again, just so you have an appreciation of this, there's a process for digging into the PLCs, digging into the controllers of the CNC machines to understand what's going on. You start with documentation. What data is available to us? Start with the code, looking at the code, the registers. What data is available to us? And then you map that data to the tags that we need. And then you start to set that up in the Kepware software and pull the data using Kepware or similar tools if need be. Then you connect the Kepware software to ThingWorx, the platform, wherever it's being hosted. Start to create the objects, the things, and then the things that are essentially the digital twins of what you are tracking of the machine, etc. And then you move to creating what they call the mashups in ThingWorx. And it's essentially a WYSIWYG of what you see is what you get kind of development environment for the screens. And then you start to create those screens and work through the security and a number of other aspects of the solution to then be able to create, again, back to these kinds of screens. So it's not rocket science. It's challenging. Every situation is different. It takes certain expertise by the people to do it, including software development, data science, controls engineering, and other security, etc. But once you have the right team, pull them together, give them the right focus, have a well-planned project, well-documented project following industry best practices, then you go through the process of the mapping of the data, connecting the data, pulling the data from the machines, pulling it into ThingWorx, and then you can also do other things like pull data from ERP systems, etc. Again, it's fun, interesting, challenging work for us, but it's not rocket science, so it's certainly viable. And then the value of this data becomes accessible to your company. A couple points here. IDC says that most companies lose 20 to 30% of their revenue every year due to bottlenecks and inefficiencies, and those are often comprised of downtime, production quality issues, and process delays. And of course, this is a pretty crazy example, but for Toyota, a minute of unplanned downtime is worth $60,000. A minute of unplanned downtime is $60,000 in lost revenue. It's crazy. It is well known to be one of the most expensive forms of downtime. Oil and gas, those numbers are even higher. Your plant might not be that high, but it's probably more than you really want it to be. And so it's solutions like this that can really help. All right, a quick look at the IoT journey, and then we will wrap up here. I definitely want to respect your time, and I already see that I'm kind of running over time here. So let's say we've solved a single problem. Great. We've created some screens. We've pulled some data from a stamping press or set of stamping presses in a cell, and we're getting better data for better decisions around that downtime. We're able to solve problems. It's real-time data. It's valuable. We're able to also maybe reduce some maintenance costs and increase some production. All of that is fantastic. Great. But what's next? If the project was successful at providing value, then the next steps typically would be to, as I said before, rinse, wash, and repeat. Push the same or similar solutions to other parts of the plant floor. Fantastic. However, it's also time to start thinking a little bit more about the solutions you're putting in place. This is where you want to get to the point of planning the rest of the journey. And a part of that journey is what you're going to do. What are your next challenges? And part of that journey is also making sure that the solutions, the technologies you've selected are appropriate technologies. But let's look at it as a three-layer cake, let's say. You have the bottom layer, which is the manufacturing plant, the top layer, which is the business unit, and in the middle layer here, and I'm simplifying the ISA 95 system hierarchy diagram, which is down on the bottom right there. I'm simplifying it and saying that most companies, like we've already heard, are communicating between the business unit, the C-suite, VPs, et cetera, and the manufacturing plant floor using paper and Excel. Yeah, your ERP system is there and you're able to do a lot of functionality, capabilities, analysis, reporting of data with the ERP system. But when you're talking about real production data, a lot of companies aren't really pulling the data directly into an ERP system. And if they are, they're doing a lot of point-to-point solutions. And so with those point-to-point solutions, could we push some production data into an ERP system? Yeah, okay, great, let's create a solution for that. Could we then take some QA data that's going to be pushed into another part of this ERP solution? Yeah, okay, let's do that now. Then maybe some work orders need to be triggered by some alerts and notifications and then sent to the CMMS. Maybe some other QA data is going to be pulled from the CMMM equipment and pushed into some other solution, a LIMS solution, whatever it might be. Each of these integrations ends up being a point-to-point solution. Over time, these point-to-point solutions are not sustainable. They're highly customized solutions and likely to be created by different people at different times with no overarching design or architecture. The idea here is to plan ahead because these solutions are just not sustainable. They're very expensive. So let's plan ahead a little bit. Let's think about where the IoT solution might go. Your company will likely rely on IoT for the rest of its existence because this technology, as we see it, it's here to stay. ERP systems, oh, flash in the pan. Nope, ERP systems are around to stay. Now IoT, Lean, Six Sigma, those are long-term solutions. And here, same thing, IoT, it's likely to be here for the rest of the existence of your company. So be mindful of the technologies that you buy, who sets it up, and how they set it up, and how that solution will connect with all of your other solutions. Because software and data systems are becoming more interdependent, not less interdependent. And those integrations are going to drive the data-driven capabilities for your company, for your management teams. And so it's better to start architecting this aspect of a company's data systems by using industry standards and best practices, and by starting to do it early. And this is where ISA 95 comes in. And for time's sake, I'll summarize pretty quickly. ISA 95 as an organization is the International Society for Automation. They establish standards and best practices for industrial automation. And the ISA 95 standard itself specifically establishes an architecture for manufacturing apps to share data to enable the business and the plant operations to work better together to increase operational flexibility and production capability. In other words, in short, it's ISA 95 standard is here to help companies work better together, produce more, and grow. And it is designed to allow you to create applications, integrations of systems that will have a long lifetime, and will help companies run in a much more well-orchestrated fashion. And this is where you get into architecture of data integrations using a manufacturing operations management system, MOM, M-O-M, Manufacturing Operations Management System. And once you actually put solutions like that in place, and PTC's ThingWorx product can fulfill some or all of this functionality, as well as some other tools that we commonly use in these situations. People will ask, maybe, can I use my BI tools to do this? Can I use the SCADA products? Those products have a specific and unique function. And that function is not doing massive integrations of data, orchestrations of data for manufacturing plants that run in very unique ways. Happy to get into more details, but cutting to the chase here, the point is that in your planning to be mindful about how you integrate IoT data into your business, you really need to be thoughtful about it, because you're laying the foundation for the future with your current IoT solutions. Please be very careful about picking that small siloed IoT product created by a startup company. Those work great, and they could be good short-term solutions, but they are, for manufacturers, they are not long-term solutions. The guy that I was talking with that I referenced earlier this morning talked about the solutions he's looking at, and he had said specifically, I do not want somebody else to own the data and to have it on their servers. I want access to it. I want the solution, and I don't want to be restricted by the solution itself. I need an open system. That's what the PTC ThingWorks solution is. So this is the kind of solution: open architecture, flexible, integrate with many things, work with tools, easily integratable with tools like Kepware, the industrial connectivity tools for integrating and pulling data from multiple systems, pulling and pushing data with other systems, built for industry, built for the enterprise. It's with those kinds of solutions that you can then start to implement standards in your IoT solutions to build this architecture and prevent the massive, expensive rip and replace project 5 or 10 years down the road when your company finds the point-to-point solutions is not sustainable. So with that, we'll wrap this by saying that, again, at the outset, manufacturers that have access to the real-time data about their operations and have the data-driven processes where they have real-time KPIs, those are the companies that are going to have the real competitive advantage. And this data that we have in some of these studies bears that out. Hopefully the technical perspective, the behind-the-scenes perspective helped you have an appreciation for what's back there. And then we've given you a few points of a little bit of food for thought. No pun intended, I didn't mean to make that pun, but a little bit of food for thought for thinking into the future about your solutions here with this 3-layer cake. So again, I appreciate your time. Thank you so much for attending our webinar. Please reach out for any questions you might have. We'd love the opportunity to talk with you. And also, I should mention too that I'll send you a couple documents that we've referenced here, these studies, and also a document, I think, as we've promised in the lead up to this event. Thank you, and have a wonderful week.